और ये
क्या करना है
मेरे वालों खला तो लगा रखा है
ये कहाँ लगाऊं टेबल पर रखूं
ना पहले उसको कर लिया और मत करो ये तो कभी भी ये बात हो गई
पीछे से
इधर जब भी बोलेगा ना तो पूरा कर लेगा पहले जब कोई रिएक्ट कर लिया
भाई साहब
I request everyone to please welcome Honorable Director Sir, Mr. MIT, Dr. Rohit Garg Sir, in the military session of 5D International Conference, IIRA 5.2. Honorable Dr. Rohit Garg Sir, Director, may I now request Dr. Rohit Garg Sir to please welcome our guest of honor by presenting a bouquet. I request Director Sir and Manish Saxena Sir to kindly present a bouquet to one of the keynote speakers, Dr. Pradyuman Kumar Pandey Sir, by presenting a bouquet. Please give a big round of applause. It is said that behind every great institution stands a visionary leader who inspires and empowers his team. At MIT, we are fortunate enough to be guided by one such dynamic personality. I now take immense pride in inviting our Honorable Director Sir, Dr. Rohit Garg Sir, a trailblazer in academia and a relentless advocate for innovation and research to address the gathering. Please welcome Sir with a big round of applause.
Honorable Chief Guest of today's valedictory function, Dr. Nidesh Kumar ji, and Honorable Keynote Speaker of today's conference, Dr. Pradyuman Kumar Pandey ji, Dean R&D, Dr. Manish Saxena ji, Convener of this conference, Dr. Rajiv Kumar, Co-Convener Himanshu ji, all other organizers of Computer Science Engineering Department who have organized this conference, dear participants, participating offline and online mode, all the faculty, staff, and dear students. Very good afternoon to all of you. I'm very happy that 2 days international conference, that is also 5th international conference in a row, that is coming to the end today. And I hope during these 2 days, you all must have been benefited by all the research papers presented by the different researchers. And I'm very happy to see the kind of response which we got this time, and approximately more than 282 papers were received as per the conference chair, and only 82 papers were selected. So this shows that we are quality conscious. We don't go for the quantity. We always believe in quality. So hats off to the organizing team and all the reviewers who have done a beautiful job, very tremendous, difficult job for selecting a good quality paper for this conference. So all the researchers who have presented, I congratulate them for presenting this research paper. It is always a very tedious task to write up a paper and present in an international conference. And this is really international conference because we were having, say, participation from abroad also. We have got research papers from outside India, and as well as the keynote speaker we were having from Portugal also. So that way, the design of this program, which were done by the Dean R&D and the conference chairman and the team members, it was wonderful, fabulous, and I hope such type of conferences will be repeated in the future also, and we will have better quality next time. And I must congratulate all the students who have participated in this conference, because I got to know that 38 papers were presented by third year and final year students. So hats off to you guys. I mean, this shows the kind of research environment we are having in MIT group of institutions. And today we are fortunate to have two professors from IIT Roorkee, that two especially who are specialized in this field, in the field of IoT, data science, automation and robotics. And I hope the keynote speaker, you enjoyed keynote speaker of Dr. Pandey. And now we would like to listen Dr. Nitish Kumar in this session. So I congratulate once again to one and all, and thank you everyone. Thanks for inviting me here. Have a good time. Jai Hind, Jai Bharat, Jai MIT.
Thank you so much, sir, for your energizing words. Your vision and leadership continues to inspire us towards academic excellence. It is indeed a moment of great pride and honor to introduce our esteemed keynote speaker of the day, with a technology innovator and a highly respected name in the field of technical education. Our guest of honor for this session, Dr. Nitish Kumar, sir. Sir has received his MTech and PhD degree from the School of Computer and System Sciences, Jawaharlal Nehru University, New Delhi. Currently, he is working as an associate professor at Computer Science and Engineering Department, IIT Roorkee. One of his works received a Special Moment Award by Xerox Research Center, Bangalore, and some other works also received several Best Paper Awards at various international conferences. He has published several research articles in prestigious journals including IEEE Transaction, Elsevier, Springer, etc. He is serving as a regular reviewer of IEEE TIPS, IEEE TBT, IEEE PDS, IEEE PNSM, and FGCS. He is acting as the lead principal investigator for several major research projects funded by the Government of India, including the Department of Science and Technology, Science and Engineering Research Board, Council of Scientific and Industrial Research, that is CSIR, and IIT Roorkee. He has also filed several patents for his inventions as an individual and in collaboration. He has been part of technical program committee members for several conferences. He has also been invited to present a keynote speaker and session chair at the various conferences, FTPs at IIT BHU, IIT Indore, IIIT Allahabad, MNIT Allahabad, etc. His research areas include artificial intelligence, cloud computing, transport cyber physical systems, software-defined networking, and regular networking. Sir, we are eager to hear your insights and valuable thoughts with us. May I now invite you to deliver the keynote address. Please welcome sir with a big round of applause.
Audible? Am I audible to all? The last, no?
नहीं.
All are my Am I audible now? Fine? Okay, fine. So, yeah, once again, the director at MIT and deans and head CSE and all the faculties and my colleagues, Professor Dr. Pandey and my dear students, very good afternoon to all of you. So, in the next few minutes, most probably I will give you an overview of deep reinforcement learning and its application in autonomous vehicles, and at the end I will also talk about a bit an application on robotic autonomous vehicle. So that is what all we are doing in our laboratory. So without wasting time, let us start the second session. So before going to the session, I must congratulate, I must acknowledge to the people from the MIT, Massachusetts University Institute of Technology. So, now audible? Audible?
Yes.
Yeah, fine, thank you. So before proceeding the session, I acknowledge to the people. Because of this, I am able to get the good context to clear out your concept on reinforcement learning. So here is my contact detail. If you want to get me in touch, so you can visit my website. You can contact me for any doubts or any related to this particular topic. Yeah. Oh, fine. So basically, these are the content that I will try to cover. Understanding RL concepts, Q learning, then we will understand differences between RL and DRL, when to say deep reinforcement learning. Then we will talk about its application in autonomous vehicle, how to train a vehicle so that it can avoid the obstacles. Then we will go for having this typically over research, how an autonomous vehicle can do the overtaking with the help of this reinforcement learning. And then we will give you one, our pre-ending idea on the technology of this robotics, how to, deploy the multiple services using the containerized based technologies, right? So let us quickly start by understanding the different classes of machine learning, so we can come to this reinforcement learning. So we know this supervised, what is supervised learning, so I hope most of you understand. In the supervised learning, we have a data that is basically in the form of X and Y. What is X? X is basically your actual data, and Y is what is typically a label. So ultimately we try to learn how to map X to Y. That's called supervised learning. So for example, this is an apple. We know it's label. This is an apple, so you can easily learn this is an apple, right? And second class of machine learning technique is unsupervised learning. So this typically basically machine learning. If you talk about the data, we have only data that's basically X. We don't have Y, so we don't know basically what is typical classes. So how basically that machine learning models try to learn? They understand the features of the data, then they try to structure the data. So basically this kind of learning can be used for the clustering. So it is looking something which is resembling to the previous data, and try to keep it into one particular cluster. So we define this is like a red, green, they are matching their shapes. It's try to put in a class like an apple. Okay? And sorry. Can you back? Yeah. Yeah, so this third most important or very powerful technique is the machine learning, that's for reinforcement learning. So why it is powerful and how it is different from the traditional ways of machine learning? Because this reinforcement learning directly try to mimic the learning from the human. How a human try to learn in our environment. This is trying to mimicking the human-based learning, so that's why it's becoming more powerful. So what is reinforcement learning? In the reinforcement learning, data would be in the form of S and A. S is the state, A is the action. So an agent, it is a particular state. It can take some action that's basically data. Reinforcement learning. So our aim is here to maximize the feature completed reward. So that I will talk about in detail. So basically, entire learning is based on the reward. Okay? So for example, here learning is a bit different. It's not like classification clustering. What is it? Here our agent knows it is an apple. If you eat it, it will keep you alive. So this is what different kind of learning. It's not a classification, not prediction, not like a regression, so on. So it's just a different different kind of learning. So, yeah. Can you go next? So now let us begin. What is basically reinforcement learning? So let us take the example of reinforcement learning. Suppose this is like one newborn baby who has recently born in the world. It doesn't know anything about the world. Can you go next? There is some environment in which a newborn baby is growing up. Next, continue. So it is observing some state from the environment. Go next. Based on this observations, it tries to take certain actions, and based on these actions, try to take certain rewards, right? So let us take the example. Suppose there is a newborn baby, which is looking one glass with the water. You know the baby usually try to hit the things, so suddenly try to hit this water of glass, and it's taking the action, taking off this typical water of glass. So this is the outcome. It is changing your environment. It means there is a water on the floor, right? So it is going to take this particular action, just hitting the water. Water is on the floor. So typically, somebody from the environment, maybe parents or some guardian, they try to sit on to this. So it's like a reward, but obviously it's not positive regard at this point of time. It's like a negative reward. So next time, this baby perceive new state. This is what the previous where it left the floor with the water. Now it is trying to take another action, trying to clean the water. Okay? So it's receiving the new reward, that's basically thank you. So here, what is that? So what is the learning here? The aim of this agent is to collect as many as thank you. So this would be a better agent. This would be a better learning. If you are receiving many thank you from the environment, it means you are a good guy. So our growth should be with the many thank yous. That's our aim of learning, right? So similarly, you can take one another example of reinforcement learning that has been widely known in many of the games. So this one of the games. This is called Space Invader game. So I hope everybody knows this particular game. So here we have an agent. I think this pen can be turned off. It's not required. It's creating some noise, right? So this is typically our agent. This agent can take certain actions. It can move left, right, and also produce some fire to kill the aliens, right? So basically, these are the aliens. Here we have a scoreboard, so it's basically reward, how much reward you are earning, that will be shown here. And obviously, there are some seals based on the left-right axis. This agent can protect from the aliens itself. So basically, this game will be turning over either this agent kills all aliens, or either this agent is killed by the aliens, right? So let us understand how this learning happens. So suppose this agent is trying to perceive the environment. From this environment, it's typically a state, and from this state, once this agent is receiving this state, it tries to take some action that's moving right, and if it is moving right, reward is 0. It is dead till any alien. In the next, iteration, it is again observing the same state. Obviously, this position has been changed. Now it is taking one action. So action 2 is basically generating fire. It is killing an alien and it is receiving reward 5. So this will be continue in the next observation, and it will continue. So after so many iterations, what would be happen? That at the iteration number T, it is taking action T. So based on this, at some point of time, it is receiving the reward RT and it is going to be killed. So the game is over, right? So in the reinforcement learning, this entire procedure until the game is going to be terminated is called an episode. So in the reinforcement learning, entire training will be the from episode. So it means you start from the random states, try to play the game until the end, continue. This becomes a multiple episode. So as many as episodes you are going to train, your agent is going to be intelligent enough. So this is just a, typically reinforcement learning. So let us quickly talk about what are the components in the reinforcement learning. So obviously the one key component is basically agent. So agent basically take the actions and environment to perform the reinforcement learning. So basically environment means the world in which agent exists and try to operate. Okay. And obviously we have set of actions. So action can be A1 to till AN. That depends on the problem. So A is basically set of multiple actions, and there is a state. This state is observed from the environment. Okay. So at the different time step, you have a different states, and obviously based on the certain actions, you also receive the reward. That's called RT. Okay. So reward is the major factor in this particular entire learning. So it's just nothing, it's like a feedback how good action has been taken by an agent in the previous iterations. This is the meaning of the reward. So, so reward is basically the important, the entire learning is based on this particular reward. So what is reward? This reward is basically not a present reward, this reward is future cumulative reward. Suppose today you are in the time step T, we are calculating reward from time step to T to end of the episode. This is called as a future reward. Okay? So this is just nothing, it's like summation from time step T to infinite. Infinite is what? Till the termination of the episode. We don't know how many iterations it will take to terminate. That's why we are putting it infinite. So this, if you expand this reward, it will be RT plus 1 and RT plus 2 till RT plus n till it will go to the end of the episode. Yeah, so in the reinforcement learning we use the one reward that's called discounted reward. Okay? So what is basically discounted reward? There is a gamma. This gamma is being multiplied with the gamma I is being multiplied with the Ri. So what is gamma? Gamma is some value between 0 and 1. So this is what I mean discounted reward. What is discounted reward? So this is something like this. For example, we are calculating future reward, right? We are estimating future maybe. For example, suppose I am taking you 100 rupees today. If I will return you 100 rupees after 10 years, the value of the 100 rupees will not be same. So that's why this is going to be multiplied by discounted, because we are estimating future rewards. So the nearby instant rewards should have more value than the future rewards. So gamma value is basically impacting like this. It's trying to normalize the interest value over the future iterations. So yeah. So you can expand this. I mean total discounted reward. So it would be discounted factor multiplied by the reward, and obviously this will continue. Yeah, so what is now Q learning? Okay, so how is this learning take place? So Q learning is like a one of the algorithm in the reinforcement learning, which is quite famous, that has been implemented with the deep learning models, sometimes we call deep Q learning. Okay, so what is Q learning? So in the Q learning we have a Q function. This function is used to estimate the estimate the importance of a particular action. Okay, this Q function is nothing. Its Q function is just calculating the expected total future reward from each state during the number of iterations in the entire training. Okay, so so basically this is nothing like it takes the state and action as the input and estimate the total cumulative feature reward. This way I make total cumulative feature reward formula. So basically I will tell you where this Q value is going to be used actually. Okay, so right now understand at every step the agent tries to estimate the Q value, and based on this Q value decides whether the action taken is good or bad. So basically this is what basically reinforcement learning. So what is actually learning in the reinforcement learning? I mean very simple question. What is actually learning? What agent is learning in entire training? In the reinforcement learning, agent is learning this particular table. This table is what? This table is called Q value. Q value table. Or sometimes we call Q table. So what are these values? Inside these values are basically Q values. That is given by the Q function. And this is treated like a brain of an agent. So basically suppose the agent, this is being updated over the number of iterations in the entire training, and after a certain point of time this is going to be saturated, then this means agent has learned enough. So what does it mean? Suppose the agent is in the state S1, what action it should take? So this table is what number of state into number of actions. So suppose agent is in the state S1, which action it will take? It will take that action is giving the maximum value. The action is giving the action value, this means A2. If the agent is in the state S1, it will take the A2 action. Similarly, it is having the all combinations if in a particular state which action should take. And this table is going to be updated over the iterations, and after a certain amount of time it's going to be saturated. The agent has been intelligent enough. Okay? So this is called reinforcement learning. So obviously there is one more term in the reinforcement learning, that is policy. The question is that the agent is in a particular state, and there can be multiple actions. It can go forward, left, right, and backward. Where it should go? How to decide where it should move? Because it is decided based on some policy. There should be some policy to decide where to map. So the policy in the reinforcement learning is what? It tries to map the state to the action. So from a particular state, which action should be chosen out from a set of actions, this is decided by the policy. Okay, so for example, one of the example of policy is argmax. So for example, there are four blocks. So which blocks is giving you maximum reward, you move to that side. That's what we call argmax policy. So there can be multiple policies depending on the requirement, right? So let us, next. Yeah. So what is typically Q learning? How basically Q learning takes place, and how to build that table that we have seen, this brain. So entire learning is based on this Bellman optimality equation in the Q learning. So this Bellman optimality equation is nothing, it's just a one particular procedure to update this particular Q table. So this table is trying to optimize your agent to be intelligent enough. So I am not going into detail because today time is limited. Just to understand right now, this equation is sufficient enough to make your agent intelligent enough so that it can be able to take your optimal decisions, where it is getting maximum cumulative rewards. Okay? So can you go next? So this is typically one classical RL algorithm with this, for the Q learning. We have a simple loop. You initialize this table, state into number of actions, initialized by any random value. You use this procedure. It means select any random state, take any random actions, and receive some reward, and move to the next state as dash, and calculate this value and update this state. This do in multiple iterations. After certain number of iterations, this would be the table converts to the particular learning. So after the training, agent has nothing, only it has this brain, and based on this brain, it is able to take the decisions. Either you talk about playing chess, playing Ludo, or any other actions in the environment. I hope it is fine. What is reinforcement learning? Now question is arises, what is deep reinforcement learning? This is reinforcement learning, and what is actually deep reinforcement learning? So basically what happens in the case of when you are having small number of states and a small number of actions, then you can go to the reinforcement, let's say L1. But when you are having large number of states and large set of the action space, then obviously you cannot solve this. This is called dynamic programming procedure, that whatever I have seen previously. You cannot solve this, this Bellman optimality equation with the help of dynamic programming. So what we try to do, we try to optimize, we try to approximate this Bellman optimality equation with the help of some deep learning network. So instead of putting the table, we are putting the trained network to the agent's brain. So this agent is enough to give you the set. This is enough to based on the states to which action you take. This is enough to advise the agent. So what is the difference between deep reinforcement learning and reinforcement learning? Basically, in the reinforcement learning, we have a table that is the brain of the agent, and the deep reinforcement learning, instead of the table, we are having a network that is approximating the Bellman optimality equation. So what is the Bellman optimality equation? This the way, or it's guiding the agent to how to take the actions. So now this network will assist the agent to select the actions. Okay? Can you go next? Yeah. So how basically, what is the difference between learning deep reinforcement learning and reinforcement learning. Basically, you are having now, there are two ways to learn. So there is a deep learning network. You give the step and the actions as input and generate the Q value, which is the ML pattern. Can you go to the previous one? Yeah. Yeah. Or either you pick a state or generate the all possible Q value, which is the maximum, select that one. There are both ways in which you can make a network learn, right? And this is typically error function. This is nothing but target value, this is a prediction value. So it's just a mean square value, root mean square value. So if you are going to optimize it, this is nothing, this is just approximating the Bellman optimal equation that we have followed in the reinforcement learning with the help of dynamic programming. So this is nothing, this later is trying to approximate the Bellman optimal equation. Go next. So let us see the typical stages in the deep reinforcement learning. So how typically deep reinforcement learning having typical number of stages? You have an environment. From this environment, you have some sensors. The sensors are sensing some data, and obviously from this data, some features are extracted, which are important to take the decisions, and then these features are represented so that a machine learning algorithm can learn them or can start executing those features. Then it goes to the machine learning algorithm like Q learning or SAS or any kind of algorithm can be there. Then it is generating some knowledge, and this knowledge is going to be reasoning part, and then based on the reasoning some planning will be done, and based on this planning certain action will be taken up, and this action will be transferred to the effectors, then effectors will be changing in the environment. So these are the typical stages from starting from environment to the action or making change in the environment. So what the component of reinforcement learning, what the component of deep learning and what the deep reinforcement learning. So this is your deep learning, red block, and entire blue block is indicating deep reinforcement learning. Okay? So if you take this example as a human, suppose you are in this world, we are having eyes, nose, these are like sensors, they are perceiving something, and then this signal goes to our brain. Brain is acting like an agent, then brain processes the data, generates some signal, then it's transferred to our actuators. Who are the actuators? Heads and legs. They are taking certain action in the environment, which is reflecting some change in the environment. Based on that, you are getting some reward or punishment, whatever. So this is typically deep reinforcement learning. Yeah. So now let us understand some application of the deep reinforcement learning that we are going to do in our laboratory, right? So can you go please? Yeah. So this is one typical problem that is you are training an autonomous vehicle so that it can avoid certain obstacles if they are coming on the road. So how we will do this with the help of deep reinforcement learning? That's problem. Okay? So just do next. Yeah. So suppose this obstacle, our autonomous vehicle is moving on the road. How it is planning its route so that it can avoid this obstacle. It should not do any kind of collision with the obstacles. So obviously, if you are able to map your problem with the key components of the reinforcement learning, then you are able to solve the problem. The major part is how to map your problem with the solution approach. So what we require in the solution approach, rest of things will be same. Major is what is your action space, what should be your reward function, what should be your state space. So state here to get the distance from the obstacle, speed, your angle and lane ID. These would be the states for an agent. Based on that, it will take the decisions. What are the actions? The throttle, acceleration, deceleration of the vehicle, and obviously steering control, brake and reverse. These would be a set of actions. So entire set would be the one set of actions. Some value will be set up. And reward function, basically we drive for the three different reward functions for the state drive or left, right. So this basically obstacle avoidance is basically complex maneuver in which basically we require actions, right and straight drive. So this combination, it requires all three combination to perform this particular maneuver. So we designed this, reward function based on this, based on this, requirement. So this entire detail is in our research paper, how we have designed so far. So I will share it very soon the link, then you can go through it. So this is typical, our architecture. So where you can see, we designed the, agent in basically three different agents. One right click change, straight drive, or left click change. So here we are having a one policy that's called center policy. The center policy deciding over the run time which agent should execute to take the access while the vehicle is performing obstacle avoidance action. So here, this is our testing blocks. Here you see the EU vehicle, autonomous vehicle. The autonomous vehicle is running. It is taking the states, and based on the state, center policy is choosing out of these three agents which agent we should choose. And based on this, policy, the agent will be excluded. And obviously, along with the execution, we also care about the safety criteria. So some safety criteria have been defined so that agents. This is critical algorithm, and this our vehicle is taking certain actions. So to test this vehicle, we take the international standards to see its effectiveness and then how good it is, how we have made the our agent good enough. So these nation highway traffic standards administration scenarios. So these are from US government. So these are typically different scenarios where we have tested in the Carver simulator. It's a very well-known simulator for the autonomous vehicle driving. So if you see the glimpse, some glimpse we have to show that how basically our vehicle or train agent is going to be able to perform the actions, right? So here obstacles are nothing. The standing vehicles are treated like the obstacles. The vehicle is standing in front of you, it's like obstacle. How to proceed? Okay. So can you play this? All videos. These are the 4 scenarios. Just here you click something or not. Very small clips are here. No. So it should be there. To do cursor every corner there should be play button here for every video. No. Maybe some issue is maybe with the system. Okay, so unfortunately I cannot show this because some template issue is there. So here you could observe, nothing is coming, system. Okay. Nothing is coming, right? Maybe this is not supporting, right? So can you find some here? Nothing? Okay, I think format has been changed. Okay. It will not work. So leave it. Just skip. So just I will save the video. They are already available on the YouTube. So we'll share for the interested ones. You can see how our vehicles work like this. Just you go there only.
Then we will review slides. Okay, we will review slides for all the different areas.
You can cross it like this. Okay, you can go ahead. It will not be played, I think. Yeah. Just make it full screen. click here. Just click here. Okay, then I think.
Slide show from the current slide.
Yeah, that's fine. So here are some results of this particular work. So we did comparison between 13 models. So this training, we have here for training, we have observed quite stable during the training. And here we compared some standard, state of the art methods. Then we checked out that our particular model is able to complete all the 8 use cases in comparison to the other state of the art model. This double tick is indicating which one is better. And this is indicating basically how safe is our, how safe decision making is in the overtaking. So our agent is having smaller distance from the any risk line, specifically the risk line while making the decision. And this one is indicating the collision rate. So our agent is having very minimal collision rate in comparison to state of the art methods. So just go next. So the same work it was done for the obstacle avoidance, and the same work has been extended with the same DRL agent for the overtaking of the autonomous vehicle. So some vehicles are moving on the road, how to perform the overtaking. So overtaking becomes more complex because here the obstacle is moving. It is not static. So just go on. So again, the model is same. Just so this work you can find it here more detail. Everything is available in this paper regarding videos, link as well as codes and theory, more detail of explanation. Just go to next. Yeah. So this similar architecture. This I was trying to show whether videos will not be playing up. Can you go again? So can you play? It will be played or not? No. Next. Here, no. This how it is working the dynamic scenario performing the overtaking. So it's again will not be play. I think there is some issue in the template. Okay. Just go next. It will not be play. Yeah. So again go previous. So these are the results of this particular work. Again in the same line, so our model is able to beat all the models in the same line. So just I would like to briefly mention, go next. One more work. That's on robotic vehicle, but if video is not being played, then I cannot demonstrate anything. So can you go next? Go next. Next. Is it being go next? It is being played. It is being played. First video. Can you go? No. No. So again, I am sorry for this glitch. That's how I was trying to connect my laptop. So basically, what we try to do in this work, we try to basically our pretending idea. Basically, what we try to do in the future, autonomous vehicles are about to come here. Obviously, they are being expressed in the US and all, Singapore and many markets. But the major problem is with the vehicle phase. How, for example, you are having a driver in your normal car. From the driver you can expect, okay, come by evening and take some vegetables. But how you can take such services from the autonomous vehicle? For example, in autonomous vehicle, your kid is going to school. Suddenly got a call, there is an emergency in the school. Then how would you control your autonomous vehicle on the go? So basically, in this idea, what we try to do, based on the container-based, cloud-based technology, we try to deploy the services on the go on the vehicle. So during the run, vehicle is going on, then we can deploy any kind of services. The vehicle will integrate with its firmware, and it is able to obey a command. It's not only command, from single command to complex function we can deploy the vehicle on the go. So this was the demonstration in this particular picture, but it is not able to run. So what we try to demonstrate, suppose our vehicle is having certain sensors, it doesn't have any source code. On the go, we can deploy the code and it is able to follow our algorithm and able to take the decisions. It's starting moving, it is starting taking left, right turn, it's starting coming back to your home. going to move on your target coordinates. So these are all kind of works we are doing in the laboratory for the robotic vehicles. So this I mean very interesting domain. So basically the interesting part is this. Most of the services are running in the backend in the container-based application. There is zero downtime in deploying services and making the execution in real time. That's the key feature of this particular work. So this we have done certain experiment, but I cannot show this I mean experiment right now because video is not working. So this I mean all about for this particular session, and obviously.
Thank you so much, sir, for giving such a wonderful lecture to us and giving so much of time.
Any question, please?
Yes, if anyone wants to ask anything with sir, he has shared some latest research works. Yes, Vanessa.
So you told that you have to deploy all the things in the cloud, and after that, if it comes back just running on the road, at the same time you want to reboot the firmware. So
No. We are not rebooting the firmware. We are building the entire firmware in the container-based application like Docker and Kubernetes. So it can easily accept your services. It start by verifying if the service coming from the right source and it's implementing the real time.
So this implementation is done on the processor that are embedded on the computer means card.
Yeah, this is done on the with the ROS operating system on the this embedded systems like microcontrollers which are deployed in the robotic vehicle, and the entire deployment is based on the Docker and Kubernetes based applications.
So we have to train like this car as a pre-trained firmware in a deployment on Docker, and Docker is
Then make it service deploy on the vehicle.
Thanks.
If anyone else want to ask something with sir. Thank you so much, sir, for your enlightening words. Thank you so much. Please give a big round of applause for giving such a wonderful lecture. Now, I would like to invite the organizing secretary of IIRA 5.0, Mr. Amit Saxena, sir, to present the conference report. The stage is all yours, sir.
Thank you, ma'am, for giving me such a wonderful opportunity to close the chapter of IIRA 5.0. The 5th International Conference on Innovation in IoT, Robotics and Automation was held successfully from 30th May to 31st of May 2025. The main objective for organizing this conference was providing a platform to bring together professionals, academic researchers, and scientific thinkers in the techniques inspired by the engineering, technological, and scientific advancement in the field of IoT, robotics, and automation. The inaugural session was graced by Honorable Professor Sachin Maheshwari, Vice Chancellor Guru Jameshwar University, Moradabad. He said about various facts about on mechanical and environment field. Before the commencement of technical session, a keynote address by Dr. Harish Kumar from NIT Delhi. He gave a wonderful speech on advancing quality as well as advanced manufacturing, exploring the role of metrology. The conference received total 279 papers, in which 4 papers from outside. Out of these, 83 papers were in the conference in the 7 technical sessions. The total 4 sessions were held on first day and 3 sessions on second day. Each session was hosted by 2 session chairs, one from the MIT and other from the other institutions. The first day was concluded with the 44 and second day was concluded with the 39 technical paper presentation. The first technical session was chaired by Dr. Rajneesh Singh and Dr. Himanshu Agrawal, second by Dr. Ajay Pratap and Dr. Dheeraj Kumari, third by Dr. Ashish Kumar and Dr. Sudhanshu Kumar. Next session was chaired by Dr. Roop Ranjan and Dr. Meenakshi Sir. Fifth session by Dr. Prabhu Saxena and Dr. Manoj Kumar Singh. sixth by Dr. Himanshu Sharma and Mohammed Saman sir, and last session chaired by Mr. Anurag Malik and Dr. Sachin sir. On the basis of presentation and feedback of session chairs, we chose 7 best papers from the each technical session. The second day of conference was started with the keynote session by Dr. Pradyumna Kumar sir from IIT on data science for AutoML and responsible AI. Thank you, Pradyumna sir, for your valuable words. Last but not least, I am very thankful to Dr. Nitesh Kumar sir for accepting my invitation to join the validatory session as a guest of honor. Dr. Nitesh sir gave a session on deep information learning in automation driving. He said with the development of deep reinforcement learning, the domain of reinforcement learning has become a powerful learning framework now capable of learning complex policies in high dimension environments. So that was from my side. Thanks to all. Thank you.
So much, sir, for presenting the conference. So before I proceed, I would like to mention that our esteemed chief guest, Dr. Sachin Maheshwari sir, Vice Chancellor from Guru Jambheshwar University, has shared some truly thought-provoking insights during his address. Let me take a moment to reflect on those as they encapsulate the essence of what this conference aims to achieve. He rightly emphasizes that motivation gets started, but commitment is what keeps us going. And he also focuses on power of collaboration. Also, he has spoken some very resonant messages such as a conference must leave us with key takeaways, new ideas, new directions, and renewed energy. And I believe every session has offered something valuable to reflect on and take forward. Sir also reminds us that research must go beyond the theoretical, it must be natural, original, and rooted in purpose so that we may solve real-world problems and contribute meaningfully to our nation's self-resilience. These words echo the true spirit of the conference, and that has been visible in the passion and perseverance of every researcher and presenter who contributed to IIRA 552. As we move forward towards the future, it's important to hear from the voices who are the heart of the conference that made this conference so vibrant, that is our participants, faculty members and students. So I now open the floor for participants' feedback. If any participant would like to share something related to our conference, like some learning, some suggestions or some expressions, let's say experiences, the stage is all yours. Anyone? Please welcome Dikshit for the feedback.
Very good afternoon, Madam President here. My name is Dikshit Kumar and I am from second year PhD. So this overall conference provides me the enlightenment and the knowledge on the things which we are learning in our classroom, how to implement that in a real world. So we are all engaging in all the activities which we are having in our classroom, that we are learning many subjects, but we all never know that how to implement that in the real world and how to solve those problems. So this conference provides me that confidence to provide them and learn those things and how to involve them and implement in the real world and how to solve those problems. I thank you all the HODs, teams and all the participants and all the members who are involved in this conference to make it this kind of vibrant. So thank you very much for organizing this for us. Thank you.
Thank you, yes, Ritika.
My warm greetings to everyone present over here. My name is Ritika Bhatt, a second year BTech CSE student. I think the conference on IoT, robotics and automation was incredibly insightful. The 2-day event was packed with incredible experiences, and I especially appreciate the focus on the practical applications of the technologies. And to get the chance to interact with other students and professionals. Overall, the experience was very inspiring and helpful. The professionals were very knowledgeable. Thank you so much.
A very good afternoon, everyone present here. My name is Aradhya Agarwal and I am from second year. I would like to express my sincere appreciation for the opportunity to attend this conference. It was truly enriching and enlightening experience for me that has broadened my academic perspective. The sessions were highly inspiring and informative for me that gave me a better understanding of how engineering and innovation can be leveraged to address real-world challenges. And overall, the conference has had a lasting impact on my academic outlook. And I'm genuinely very thankful to all the experts and organizers to give me this wonderful experience. Thank you, Aradhya. I would like to request Dr. Sudhanshu sir to give his valuable feedback.
Thank you, Rajan. Director, sir, eminent speaker, both teacher and Kumar Pandey, dean sir, conference chairperson, co-conveners, participants, faculty members, and my dear students. Very good afternoon to all of you. My overall feedback regarding this conference was positive. I was involved in session track 6 along with Sakshi and Salman sir. I observed that the participants are conducting research in cutting edge such technology like you can say nowadays machine learning are very popular, deep learning, reinforcement learning. Ultimately, the purpose of research is to address the challenges currently faced by society. Our researchers, our students, and the participants who are using this technology in society challenges like you can say agricultural things, they are using technology in IoT based application, security based application. So overall, this conference is definitely beneficial for both society and our students. And definitely, I thought today I thought track 6, our conference, our student conference is useful. So, and I sincere thanks to our department for organizing such kind of conference. And I hope in future also department organizes such kind of conference. Thanks. And I thank to Pradeep Kumar Pandey sir and Nila, these sir, Nila, to for their respect.
Thank you so much, sir. Now I'd like to request Dr. Neeraj Kumari ma'am to give her valuable feedback. Shall I provide the mic over there?
Thank you, Mr. Ma'am. A very good afternoon to everyone present here. Myself, Dr. Neeraj from CSE and department. The feedback that I want to give related to the conference that is positive from my side, and I am having some points related to the conference feedback that I would like to start from the theme of the conference. The theme of conference is truly very impressive and that explores all the research areas in the CSE department. Now the second is organizing. If we talk about the organization of the conference, so I would like to say that the complete conference was organized in a well manner that is insightful and trying to cover all the research areas. Although all the sessions related to the conference was successfully executed, but the two sessions, the one is the keynote speaker session and second one is the technical presentation session that was very informative. And finally, I want to conclude the feedback with a statement that the complete management of this conference was truly smoothly executed and
professionally good. Thank you. Thank you so much, sir. I request Dr. Saurabh Srivastava sir to kindly share the feedback videos of our participants who have joined us online.
Hello everyone. Thank you. So, looking at research paper, I was just international concept on innovation in IoT, robotics, and automation, that is IRA. A household has to all software, container, and entire information is well structured and reaction efficiently. The was not only inspiring. Good morning, myself Dr. Gaurav Kumar. I am assistant professor at IIM University. I got an opportunity to present my research at IIM University. My sincere thanks to Dr. Neeraj Kumar, Dr. Ajay Pratap for getting insight for bringing into my research. And sincere thanks to this lecture for smooth conduction of the session. Further, I extend my thanks to Dr. Rohit Bell, Dr. Ajay Kumar, Mr. Students, or Srivastava, as playing for the such a nice research platform. And I further extend my thanks for getting selected as best speaker for the session.
Hello everyone, I am Panch Kumar and I had the wonderful opportunity to present our research paper linked with the system and the fifth international conference in innovation, IoT, robotics and automation. It was an amazing experience to be a part of this prestigious platform that fosters the exchange of innovation ideas, cutting edge research. The session was insightful and interacting with fellow researchers is truly inspiring. I sincerely thank the organizing committee well-managed and impactful event. Looking forward to participate in the future events as well. Thank you.
Jai everyone. My name is Darshan. And today we are talking about the conference of MIT. It was a great conference to me. And I also present my thoughts on the research paper which I have written on the crop rotation system. And it was a great conference to me. The judges are too good, and the overall management team is also good. Thank you.
Hi, my name is Mahesh Gupta. I am from Ajay Kumar Engineering College. Yesterday, I had got an opportunity to present my paper authoring AI-driven feature system in RIRA 5.0 conference, which was organized by Moradabad Institute of Technology. It was a great experience presenting my paper there, and it was a great time learning and listening to other professors as well. And thank you, Moradabad Institute of Technology, for organizing this conference. Thank you.
Greetings of the day. My name is Kalifa. I am from Chandigarh University. And recently I had the opportunity to present my review paper at IIRA 5.0 conference held by Moradabad Institute of Technology. I attended the virtual session and it was a great experience to be a part of a platform that invited various researchers to various fields. And I got valuable feedback from my peers and experts on my paper. It was a great experience. I look forward to participating.
Thank you. Thank you for all those encouraging words. Your feedback is what makes this platform thrive and evolve every year. So now comes a very special moment. So we now proceed with the distribution of certificates to all our paper presenters and participants. Okay, so we now proceed with the distribution of certificates to our paper presenters and participants. In this row, I would like to invite our guest of honor, Dr. Nitesh Kumar sir, Dean R&D, Dr. Manish Saxena sir, and our keynote speaker, Dr. Pradyumna Pandey sir, to do the honors. Please, sir. At the very first note, I would like to invite Mr. Rohit Kumar Singh sir, the first presenter, followed by Manoj Kumar Agrawal sir. Dear participants, please keep coming to the stage. Dr. Monika Gupta ma'am, all the participants, this is your certificate. Please welcome each and every participant by encouraging, by giving a big round of applause. Yes, everyone. Anu Sharma ma'am.
Video.
Ms. Shivangi Sharma. Shivangi. Sakshi Chauhan. Sakshi Chauhan. Please hurry up. Piyush Kumar. Piyush Kumar. Vipin Chauhan. Vardhan Singh. Salim Ansari. Shivam Prajapati. Tanzeen Malik. Mohammad Bilal. Ankita Bhatnagar. Ankita. Ashtika Bhatnagar. Adil Ahmed Khan. Followed by Vikas Kashyap. Akshit. Arin Saxena. I welcome Dean Academics Dr. Kshitij sir and HOD Electrical Engineering Raju Mishra sir and Dean Student Welfare Dr. Animesh Agrawal sir in this valedictory session. Please give them a big round of applause. I request Kshitij sir, Animesh sir and Raju sir to please join us on the stage. Please sir. Soumya Pawar. Next in this row we have Soumya Pawar. सुनीता भट्ट, अनुभव कुमार, अनुभव कुमार, अंकित सनी, अजय कुमार, अली मलिक, मानिक रस्तोगी,
उनका ले लो, उनका ले लो, उनका ले लो।
आर्यन वर्मा, आर्यन वैभव नेगी, Kashish Agrawal, please come first. Now I request Animesh sir to join us on the stage. Vansh Sharma, Mansar Saluja, Utkarsh Saxena, Tanishka Ruhela, Kashish Mathur, Hitesh Kumar, Atufa Javed, Anjali Negi, Sarthak Rastogi, Sujay Chauhan. I request Himanshu sir to please join us on the stage to distribute the certificate. Also, I request Nilaksh sir to please join us on the stage. Dr. Nilaksh sir, Samran Nawab, Himanshu, Aditya Kumar Singh, Mohammad Zaid, Utkarsh Chaudhary, Utkarsh, Utkarsh Chaudhary, Anvi Saxena, Mohammad Talha, Vidhi Chauhan. Now I request Manoj sir and Anurag sir to join us on the stage in the certificate distribution ceremony. Anurag sir. Nishant Sharma, Nishant, Dhananjay Pratap Singh, Rachi Singh, Shivi Yadav, Simran Sarfaraz, Evan Chaudhary, Archie Rastogi, Astha Soni, Ankit Kumar Mugdal, Ashit Kumar Mudgal, Akshit Bidam, Ask the God and Tahir Ali. Thank you so much, sir. Thank you so much, sir.
अभी लाइट के भाग पूरा नहीं मानता हूँ ये गलती
Please welcome Honorable Trust Member Adarsh Sir and the validity session of 5th Day International Conference on IIRA 5.0. Thank you so much, sir, for joining us in the session. Please welcome him with a big round of applause, everybody. Now comes a very special moment, that is the recognition of outstanding research. One of the highlights of this conference is the recognition of exceptional research. It's now time to announce the Best Paper Award for this edition of IIRA to commend exceptional contribution from our presenters. And for this, I would like to invite Dr. Adarsh Agrawal sir and Dr. Rohit Garg sir to please join us on the stage. Thank you, sir. Manish sir, Nitesh sir, please join us. Sanju Pandey sir, please join us on the stage. Let me take the privilege to announce the name of the Best Paper Awards. The very first is Rohit Kumar Singh sir. Please welcome him with a big round of applause. Next is Ms. Rashmika ma'am for home automation. Please welcome her with a big round of applause, everybody. Welcome, ma'am. Ms. Meenakshi Yadav ma'am for blockchain and deep learning based multiple factor framework for real-time deep fake detection. Meenakshi ma'am. And our one and only Dr. Saurabh Srivastava sir for connecting details with smart chefs and inventor management. Dr. Saurabh sir, Saurabh Srivastava sir.
अब आगे आ जाइए।
I request Director Sir and Adarsh Sir to present the guest of honor, Dr. Nitesh Sir, to felicitate him with presenting a certificate. Nitesh Sir. Also, as a token of our deep appreciation and respect, I request Honorable Director Sir and others Sir to present a memento of gratitude to our guest of honor, Dr. Nitish Kumar Sir, for taking the time to be with us today. I kindly request the dignitaries to present the certificate and the moment of appreciation to our keynote speaker, Dr. Karnan Kumar Pandey Sir, as a token of regards. Thank you so much, sir. Now, I would like to invite Dr. Himanshu Agrawal sir to give the vote of thanks to everyone who made this event a resounding success. Please welcome him on the stage.
Thank you, Mr. Ram. On behalf of Computer Science and Engineering Department, I, Dr. Himanshu Agrawal, extend my gratitude to all the keynote speakers, especially Dr. Pradyuman Kumar Pandey sir and Dr. Nitish Kumar sir for sharing the Ganga of knowledge with us. Thank you so much, sir, for enlightening us and to give your valuable insights. I am deeply thankful to the Honorable Chairman and Secretary of MIT and all other trust members for providing such a platform where intellectuals can meet, interact and share their expertise. A special note of thanks to our dynamic director, Dr. Rohit Garg sir and Dean Computer Science and Engineering for their continuous support, motivation and guidance throughout this event. I also wish to thank Dean R&D, Dean Academics, DOSW, HOD Electrical Engineering, HOD Mechanical Engineering for their timely suggestions and constructive feedback. Last but not the least, I am very much thankful to all the organizing team members and all seen and unforeseen parts to make this event successful. Thank you. Thanks a lot.
Thank you so much, sir. With this, I officially bring the voluntary session of IIRA 5.0 to a close. Thank you once again for your perseverance, your participation, and your passion. Now I request everyone to please rise for the national anthem. जय गणपति अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड़ उत्कल बंग विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाए तब जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे। Thank you so much. भारत माता की जय। भारत माता की जय। जय हिंद। Thank you all. Please take your seats. Dear participants, please take your seats.
Please take your seats. I want a photograph of the